All right, let's get everything powered up and let's see how it performs. One, two, three, and let's turn off the power. 4. Okay, sorry about that. All right, here I have some metal washers. If I place them over the coil, I can see how they react with magnetic field, and I can visually see the magnetic energy coming out of this coil. Right now it's not putting out anything. If I give it some juice, you can see these washers. Okay, so right now we're running 78 volts being stored into these capacitors, and anytime I apply frequency to the MOSFET, it's gonna unload the stored energy into the coil here. I have my Tesla meter here, and we can perform the measurement. I have it set up to pick up the highest value. If I place my probe here, I can read the power output from it. So right now it's in a 10 Hertz mode. Right now it's set to put out 10 Hertz, and I'm gonna increase the duty. Right now the duty is 0, and as soon as I increase the duty, this will start pulsing, and we're gonna have some readings here. So let's go ahead and do it. 1%, 2%. Just watch the number here increase. We got 0.03 Tesla, 0.049, 0.099, 0.1 Tesla, 0.135, 0.1577. That's the most I can get. 0.18 out of this 0.19. And let me show you how washers are. You see how much energy? It's got quite a bit of energy, and it's only 0.2 Tesla. 0.2 Tesla output. All right, I'm gonna decrease the power duty, and I will go ahead and lower it to 1 Hertz, and we'll set 1% duty with 1 Hertz. So every second it's gonna pulse at once. So check this out. See, this is 1 Hertz. Now if I increase, this is 2 Hertz. This is 3 Hertz. This is 5 Hertz. Increase the power. 6, 7, 8, 9, 10, 11, 12. 12 Hertz. Now let's increase the power. 1, 6, 7, 8, 9, 10, 11, 12%. Let's do 20%. All right. Let me show you the next voltage is not 79 volts. This is 79. The next would be 160 volts. Check this out. 166 volts now is stored into these capacitors, and now we're working with 166 volts instead of 78 volts. So let's see the effect of doubling the voltage. 12 Hertz. Let's go ahead and increase the duty. Much stronger, much stronger. Only 5%. Look at this, guys. 6, 7%. This is violent. Violent. Let's go ahead and take measurements. So on the first setting we had 0.19 Tesla. Let's go ahead and measure it on the second setting. One percent, 2%, 3, 4, 5, 6, 7, 8, 9, 10%. Now we got 0.32 Tesla, 0.24, 0.25, 0.26, and our circuit, burst circuit, starts kicking in. So I'm driving more than 300 watts, and this is sensing it and turns off and makes it so that it's bursting. Check this out. See? It's bursting. And we got 0.369 Tesla in a at 18, and you can go to 20%, which is safe, and at 20% you get 0.38 Tesla. All right, I'm gonna go down to 0 right now, and I will increase the voltage. I'm gonna increase another 80 volts, and we'll see what happens. So let's go ahead and switch the next. So by increasing another 80 volts, we got to 245 volts right now stored into these capacitors, and that's what we're gonna play with and discharge it into this coil. All right, same 12 Hertz, 2, 3%, 4, much stronger. Much stronger. Much stronger. Let's go ahead and take some measurements of this power, and so we have the number. All right, 3, 4, 5%, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 19, 20%. Well, we got 0.5 Tesla. It's bursting. It gives about 5-6 pulses every burst, but we got 0.5 Tesla coming out of it. Half a Tesla, guys. Check this out. So strong. This is like crazy. Like a funny. All right, so I'm gonna decrease the power here, and what we're gonna do is go next step, which is right now we are 247 volts. Let's go ahead and flip the next, give another 80 volts, and we're gonna land it about 330 volts. Awesome. 330 volts now is stored into these capacitors, and let's go ahead and play with 330 volts and see how much power we get. All right, I will perform the measurement and slowly increase duty up to 20%, and we'll see how much power we're gonna get out of this coil. So by the way, let me get out all the washers from inside. Okay, Tesla meter is ready. Increasing duty, looking at the numbers. 14, 15, 16, 18, 19, 20%. All right, we got 0.7 Tesla, guys. 0.7 Tesla, 0.72 Tesla. And that's bursting at 12 Hertz. 20%. You hear that? Like tick, 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 tick. Hear that, huh? All right, I'm gonna go down to 0, and what I'm gonna do is increase another. I'm gonna add another 80 volts. So this is the last setting, and this is the highest output that you can get out of this unit, out of this setup. And check this out, we're getting 410 volts, 411 volts right now stored in these capacitors, and we're gonna be discharging this 411 volts into the coil, and let's see how much we're gonna get now. I'm excited. This is some power, you guys. So let's see. I'm gonna slowly increase to about 20%. Now you hear this, and watch the Tesla meter. There we go. 0.0913 Tesla. 0.0139, almost 1 Tesla in a burst mode. And that's running at 12 Hertz. Now, if I decrease the power, decrease the duty, now it's continuously pulsing because I am below 300 watt of power consumption. Anytime I go over 300 watts, it switches into burst mode. All right, I'm gonna turn it off. Coil is getting warm already. This is about 10 pounds coil, you guys. This is 14 gauge, 1 inch internal diameter, and I believe it's 5 inches, 5-6 inches external diameter. Let me see. 5 inches, and it's about 2 inches deep. This coil is 2 ohms. If you measure with ohm meter, it will give you 2 ohms. I don't know the inductance of this coil, but this is a massive coil, pretty heavy. Alright guys, what I want to show you right now is how this performs at highest frequency, which is 600 Hertz, and the power output at the highest frequency on the highest voltage, which is 415 volts. So let's go ahead and take a measurements. Let me show you what it can do. So I'm gonna slowly, I have reset the values here, and I'm gonna slowly increase the duty here to about 8%. That's when it's gonna start, and I'm gonna increase it to about 20%, 25%. And let's take a measurements. I think that's it. 0.395 Tesla. Let's see if I can get a little more. 0.4 Tesla out of it. There we go. 0.458 Tesla, guys. 0.458 Tesla at 600 Hertz. Alright, you guys. Now you've seen my circuit. You've seen how it performs. If you like it, I would appreciate if you give me a thumbs up, and subscribe to my channel if you haven't done it yet. Share this circuit if you can. If I get enough interest from you guys, I will go ahead and open source this model. And as you see, it's got a bunch of features, and you're probably not gonna find one like that. So just express your interest into it, and I'll see that you guys like it and want it, and I'll go ahead and make it available for anybody else who wants it, to build it and to make it happen. Alright, I'll see you next one.